Okay. Hello, everyone. Hope you've all got some food. It gives me great pleasure to welcome Nick Feamster from University of Chicago, who's here as our next Distinguished Lecture Series speaker. Nick has a very, very long bio, so I shortened it because he's done amazing things. He is the Neubauer Professor of Computer Science and the Director of Research at the Data Science Institute at the University of Chicago. En route, the path went through Georgia Tech and Princeton for a number of years. His research is very interdisciplinary and it spans many aspects of computer networking systems with a focus on network operations, security, and censorship-resistant communications. He's an ACM fellow, of course, and he's received numerous awards, including the PKAs, the DR35, so many, many awards and lots of best papers. And I was looking at it in all different communities. His seminal work on routing control received the Usenix Test of Time Award. And I'm really, really excited to hear your talk and hear about your 15-year arc.
Thank you
on the project.
So. Thank you.
Yeah.
Thanks. Thank you. Oh, yeah. Thanks. It's nice to be back. I think the last time I was here it was maybe 15 years ago at least, and I think I made the error of talking about my most recent work instead of the work that maybe has that I'm maybe the most proud of over the last 15 years or so. And so this time I'm giving you a long arc talk, which was really started, probably around 20. Yeah, I was telling Dave as we were walking around this morning, just probably after I last visited here, 2009, 2010. One of my collaborators at the time, who's pictured here, Renata Teixeira, who now she's now at Netflix, came to me with a data set from France. And some of you are maybe old enough in the room to remember a website called DSL Reports. DSL was the thing. People used to get internet that way. But the site basically, there was a French version of it where people would take measurements and they'd say, hey, I basically got this speed on my ISP connection at home. Doesn't appear to match up to what the provider says that I'm supposed to be getting, what gives. And the site was called Grenouille, which I think means frog. Is that right? Yeah. So don't know why. But in any case, she came to me and she said, yeah, actually, I've been talking to these people and I have this data set. It's like all these throughput measurements, latency measurements, et cetera, from this group. And we'll write the paper and we'll, just make a few plots and we'll be done. We'll just talk about what people's ISP performance looked like, across France. Super cool, right? And then one of the first things we did was just kind of plot a distribution of the download speeds that existed in this data set. There were other weird things in the data set, which I'll come to sort of, where it led us on the path, including things like negative round trip latencies and other things. But this one, I think when we started to look at this, it was the very first outer layer of the onion, which was on the x-axis here. I have the 95th percentile of the download speed that the user in this data set seeing, divided by the advertised, what the ISP is saying they should get, the advertised service level agreement. So one would be, okay, the user's getting what they're paying for, and then anything to the left of one here would be some fraction of users who aren't getting that. You could see basically that a lot of people weren't getting that. In this day and age, maybe that's something you've heard before, but this was 2009, 2010, and it was okay. And then each line is a different ISP in France. And so we're okay, well, that's curious, except we didn't collect this data set. So we just have no idea. It's just numbers in numbers in a spreadsheet, right? So we have no idea what software was used to collect this, the conditions that were, experienced were these home networks, were they, were people plugged in? Was it Wi-Fi? Which had no idea what was going on. And so we could basically report on the data, but we had no way of getting actual insights. And so that was kind of the start of this journey, which I'll kind of keep coming back to throughout the talk, which was really like simple questions like this where it's like, oh, what's the speed of my network? Or am I getting what I'm paying for, right? And then you think like that's going to be easy, right? I can state that to you, I can summarize it, like, you know, many people outside of this room on the street could understand it. It turns out to be like super hard. So people maybe now since then, right, maybe familiar with this like UI, anybody seen this, right? Yeah, right, exactly. So people run it maybe. So one of the first things I don't know what people see when they run it, but one of the first things I do in a networking class I teach is I ask people to run it. And just tell me what you get, like, you know, type it into a Google form. And then you get something like this. I don't know which year it was that I did this one, but they basically all kind of have this curious shapes, shall we say. This is a histogram of speed. So everything from like, and this was like some campus Wi-Fi at the time, right? So like everything from like 5 to 85 and lots of things in between. And then we have a long discussion about like, well, what could be causing, you know, all that. And it's everything from like, well, we're all running it at once and there's Wi-Fi and there's contention and, you know, I got a different server than you and, you know, I'm on an iPhone and you're on an Android and this person's on a laptop, right? So there's all kinds of different things that are going on with these measurements. Why that matters, I think, you know, sort of crosses over to another area, which I'm going to get into like throughout the talk as well, which is starts to step into policy as well, right? Because when decisions are being made about how to allocate resources to improve, let's say, the internet infrastructure in this country, and this is the data that we're dealing with, that becomes an interesting question at the intersection of the tech. Like, how do you actually do these measurements, and then how do you basically make sense of what numbers are being produced? Because no matter how hard you try, like you're never going to get it totally. There's always going to be limitations. So what I'm going to do, like in the first part of my talk, is really talk about a little bit more about speed testing. Okay, so I'm going to talk about like, hey, this problem, right, that was brought to me by, you know, the French frog, turns out to be like super hard, and that kept us busy for a while. Then I'm going to basically go beyond that. We're going to talk about application performance, and then I'm going to go beyond that and talk about, well, everything I'm going to talk about in the first like 45 minutes of the talk is single user, right? Like, what's my experience? And then more recently, what I've been working on is like, well, how do you talk about the experience of like a neighborhood or a geography or a demographic? So that's kind of where we're headed. But for now, let's just sort of stick to speed testing, which was, you know, was super relevant from the time I started thinking about this in 2010 until maybe, I don't know, one could argue that maybe it's still somewhat relevant, but we'll see the ground shift. So in 2020, I wrote a paper with one Jason Livingood, who's a VP of engineering at Comcast, who then got in. I think now he's like a VP of, you know, tech and regulation, government regulation for Comcast, which again is a separate story. Why was he really interested in writing this? I'm going to sort of leave that out of the talk, but you can imagine that ISPs also kind of you know, at the boundary of regulation, also kind of interested in the speed tests, accurate speed tests. So we wrote this paper for Communications to the ACM that sort of talks about like all the different reasons that client speed, like measuring internet speed from a client, turns out to be hard. And I'm not going to go through like all of these because that would probably be, you know, a fairly, you know, tedious march. But what I'll do is sort of highlight a few of them by way of example and some of the experiences that we've had over the years. So I'll give you like 3 or 4 greatest hits, each of which have become like research papers or in their own right. So so I'll talk about device capabilities, you know, how different devices basically can affect tests and things that have shown up there, how test design has also affected test accuracy over time, Wi-Fi network environments, et cetera. So I'll talk about a few of them by way of what I think are kind of interesting anecdotes. And in many ways, what I'm about to talk about for the next 5 or 10 minutes is sort of like obvious in hindsight, except what I think makes these interesting is they were screwed up in fairly like high visibility, large scale ways, so or sort of high stakes ways. So around 2017, the New York Attorney General sued Charter Communications in the state of New York based on what I've been talking about to this point in the talk, which is like, hey, you're advertising these speeds that you're just not providing to your consumers. And there was a fairly large settlement in that case. And some of you may know me here, Kishir Sagar, who's at Princeton CITP now, who I met actually because we were both involved in this case. There were, I think the Attorney General got a reasonable settlement because there were some inconvenient facts there, such as, if you're selling a Wi-Fi access point that can't actually deliver the speeds that you're advertising and putting those in consumer homes, and that's sort of fairly damning. However, because there were other aspects to the case, and because I was had been thinking about speed testing for more than 5 years at that point, there was a tool, a client-based tool that was being used very heavily in policy circles, and it was just really it just kept it was keeping me awake at night. And I saw it used in this complaint, and I was like, oh, man, why do they keep using this tool? So I got involved in some of the data analysis as far as the speed test data that was supporting the complaint. And what I'm going to show you here or what I'm showing you is actually these are box and whisker plots showing distribution of speed tests received using this client tool. This is the Measurement Lab network diagnostic test tool for those of you who are in this space. But okay, so you have this box and whisker plot. So here's the red lines are medians. This is 0 up here. We've got, it goes as high as 350. So things look pretty rough. And then here's your advertised speed tiers, 50, 100, 200, and 300. So you would expect these to be way up here. Okay, and this, this would on the surface look fairly bad. Not looking good for Charter, except once we broke it out by devices that were performing the test, the other thing I've got on the axis here is 5, 5S, 6, 6. So those are iPhone models. And the older iPhone models actually didn't support 802.11ac. So the speeds of those radios never exceeded 100 megabits per second. So actually what was going on in this particular data in attempts to kind of support that that claim was just bad data from the client. Another issue that can come up is the design of the test. And actually this one, I should have redone this graphic for the Pennsylvanians here. There was an article, I guess, in the this is not Pittsburgh, but this is somewhere in the center of the state, I guess. Staggering discrepancy in Pennsylvania between rural and urban broadband coverage. Study finds. I'm sorry, I obscured it, but basically Philly's somewhere over here, and actually what the study also found was that Center City, Philadelphia also didn't have broadband internet access. So it wasn't just the rural areas, it was actually wait a second, you've got gaps in broadband where clearly something else is going on. I'm going to come back to urban at the end of the talk because it turns out that there are gaps in urban connectivity as well. But what was actually going on in this particular case was, again, the design of the tool was such that it was not to get into too many details about speed testing in a short hour-long talk, but the goal here is essentially to depending on what you're trying to do, and that becomes a policy question. What are you trying? One way to do this is to shove as many bits across a network path as you can, and then measure how many bits you manage to get across, and then figure out how long it took, and then divide, right? So bits over unit time gives you some throughput measurement. Now, there's a bunch of different, even in that metric, right? I just delighted, well, what path? And do you count the beginning, and et cetera, et cetera. But another thing that you can ask is well, if I'm trying to push as many bits as possible, do I use one connection or do I use 4 or 8 or as many as I can? This particular test used 1, okay? Which was fine maybe when speeds were 3, 5, maybe 6 megabits per second. But this was actually, we did this back in 2010 when we first started working on this. This was tested on a 10 megabit per second DSL link, and even then, a single this black circle, this is like a single connection, single TCP connection speed test. And we basically got, this was like 3 or 4. And just for reference, Ookla speed test, the one that everybody was like, yeah, I run that. That does something where it starts with 4, and then if it sees that it managed to fill the pipe quickly, it actually it continues to expand up to like 16. So anyway, these folks decided they were gonna design a test with one single TCP connection, which with predictable results. The long story about that I'm not going to get into now in the limited time, but you can imagine this starts to become a technical question and a policy question. It's like, well, what are you trying to measure? Most applications, right, including your browser, use parallel, many connections in parallel. Well, you're trying to measure something like that with speed, or are you trying to measure like the capacity of a single TCP connection over a network path? I'm going to come back to that a little bit later. So we kind of knew that there were issues with those test designs like way back in 2010. It took us like almost 10 years to write the paper that I wanted to write, which was to do a comparative analysis of these tools. So it took a number of advancements, some ours, some other things like, thank you for, more powerful Raspberry Pis and the ability to, actually run things like Ookla Ookla speed test on embedded devices, et cetera. Fleet management software, all this stuff basically made it possible for us to do a fairly large field test of like, not simultaneous, right? But there's some test design to think about here that I'm not going to get into, right? But like essentially contemporaneous measurements in broadband access networks of like, what do we see when we run an NDT test? What do we see when we run Ookla speed test, et cetera? And kind of an obvious thing in hindsight to do, right? It's like you got a network to measure. Let's like look at what these different tools do under like ostensibly as close to the same condition as we can measure. It's just that nobody had actually done it. And so what we started to do, what we did, and then what we started to see over time as we looked at this was like, hey, wait a second. And now we're like into 2021, right? So these networks are faster. We're up at like, hundreds of megabits per second. And green here is like Ookla speed test downstream. So we're measuring downstream throughput here. Cyan is the NDT test downstream. So let's just pay attention to this. It was like, wait a second, like this, this speed test is only running, at a fraction of the network capacity consistently. What's going on here? And so whereas the earlier question was about like number of TCP connections, this was actually, turned out it was like a programming issue. It was a software, I'll call it a bug in this case, but essentially the way that they were doing memory allocation in their speed testing tool created a bottleneck because of the way that they were allocating memory from their buffer pools, and that was actually a bottleneck. Fixed, thanks to this paper we wrote, which appeared in Symmetrics a couple years ago. But the data from the old tool remained without annotation. So that's a footnote. Another thing that obviously creates complications for client-based speed testing is that sometimes people are measuring on their Wi-Fi networks. And again, back in 2010, like this was not as much of an issue with like the speed test data, right? Because like a lot of people didn't have Wi-Fi, and actually even if they did, it was like 802.11b or whatever, and like still it was somewhat crappier than your wired connection. And so a big thing that sort of happened over the tools didn't change, but the access networks got faster, and so the bottlenecks got pushed everywhere. They got pushed to devices, to Wi-Fi, to the network path you were choosing, to the speed test server, et cetera. And Wi-Fi was just one of those. So we had written a paper like fairly early on, 2013, 2014, to look at this. And we wrote another one actually just last year on it. We finally managed to the first one was done in a very sort of like old school network queuing theory kind of way to sort of place bottlenecks. the paper that we wrote last year, finally we were able to, thanks to, again, like, technological advances, we were able to like do I haven't described our software or like where we deployed it just yet, but like a lot of what we ended up building was speed tests running on embedded devices attached by wire to a user's home router or modem, right? So we did a bunch of speed testing from that location in the network, but then because we had that, we were able to measure the wired throughput that the ISP was delivering to the wall jack. And then what we did is we added a browser plugin, right? That would allow us to run a speed test from the user's browser wherever they happen to be sitting in their home to our device. So that device that we had dropped in participant homes was both an ISP speed tester and a server for measuring the Wi-Fi. And then we built a plugin to make people actually want to like, use the thing. This was, I guess I was probably sitting like on the other side of a brick wall. I picked a, particularly inopportune time, but this was like an example of like, okay, this is what I'm getting from the wall jack, and this is what I'm getting like on my browser at this time. And so that allowed us to get both, like on demand, and also the browser plugin would do continuous measurements. And we were able to get data that gave us the results that you would basically expect. And the story here has been, this is one of these things where technology advances, the numbers change, but the story like is the same. When we did the older version of this, like back in 2013, 2014, it was like, yeah, Wi-Fi is a bottleneck, at like above 25, 30 megabits per second. Now we see like, again, this is a CDF plot. So like, and it's fraction of our measurements, I should say, where we see a lower throughput in the Wi-Fi versus on the access link. So you can imagine like, and this is measured speed from our device out on the wall jack. So you can imagine like as the wall jack speed increases, the prevalence of your Wi-Fi bottlenecks increase. Again, not something that maybe would surprise many people now, but one of those things that had not been measured, and also one of those things that, like, for policy, matters, right? To as we consider, things like what is the user's lived experience, right? And so this is something, I guess, from all this, I think we're still pulling the pieces together, on like, I've talked now for the first part of the talk exclusively about like getting a single number, referencing like a throughput that a user's getting by running a test. But if we think about like why we're doing any of this, it's, whether we as like the ISP or the consumers or the advocates or the regulators, it's like, well, presumably we're doing this because we want people to have like a good experience on the internet. Like we want them to be able to work and learn and recreate and do what they want to do. And as early as 2013, we had started to think about this. Now in 2025, it's like even more front and center. And this next part of the talk, I'm gonna get into that. But this was credit actually to another theme that's going to come up throughout this talk is that like that I didn't think of any of these questions. Basically, they were put to me. This one was put by Walt Johnson from the FCC. I'll get your question when I finish this thought, which is that he said, hey, wait a second. The FCC is like doing all this broadband measurement stuff, but we're not measuring applications at all. Like we're not measuring like web. And I think like basically web page loads don't get faster at a certain point when user access speeds or throughputs increase. Can we like measure that? And so we did that. We worked with the FCC and their contractor at the time to design their web tests. And that's exactly sort of what you see here. The punchline is here, so I can let you read it, and I'll take Vyas's question. Yeah.
I'm just curious. You've done a lot of these measurements, right? Is there a version of the Volkswagen emission scandal problem here that the tests look really good, but the actual performance is terrible?
Yeah, there's a lot of like.
There's
a lot of like gaming stuff. In fact, there was one. You can search the MLab support list where like Cogent engineer basically admits to gaming it like straight up on the list. He's like, no. We look at the DSCP bit in the packets, and we basically and it was like a jaw drop moment. So absolutely, the tests can be gamed. Yeah, maybe we can talk about that more later. But no, this is actually it's for the regulator. It would be a concern. Yeah. So that got me thinking about that was 2013, and we had started to work on that, and now credit to some Wall Street Journal investigative reporters who said, "Hey, we saw your paper on the web performance thing, and like all these people are like calling us, and they're saying like we're calling our ISP, and we're complaining about our Netflix performance, and the ISP just tells us to like upgrade the service plan and go away," which of course they've got a lot of incentive to do, right? And so they're like, "Can you look at that?" And we're like, and I was like, "Yeah, that we should be able to do that," because like we've been doing the speed test thing, like, and then I had in my mind like, okay, we can put on the x-axis, we can put the speed test thing that we've been like figuring out how to measure for the last like 5 or 8 years. And the y-axis, we'll just do some kind of like application performance thing. Like that should be pretty easy because like Dash, the video streaming protocols, like we understand those, we know how those work. So this should be pretty easy. Straightforward question, right? Like maybe not so obvious that maybe you don't even do it because it's like, I mean, simple plot, right? Except like this other thing started to happen around 2017, which was the encryption of the web, right? And so this idea that we were just going to basically look at the HTTP protocols that like Netflix and Amazon and Twitch, et cetera, were using, and we'll just look in there and figure out like what resolution segments they're asking for, and then we'll like plot that against our speed test, calculate some frame rates, and be done. So that turned out to be like not quite so easy, right? Because traffic was encrypted, and then we wanted to do this like real time is not quite the right word, but we wanted to do this at a fine granularity. So that led to basically, I don't know, another 5 years of research, building the models to do that, and actually we're still doing that. I'll come to that like as I finish this part of the talk. Fortunately for us, I think maybe VS and others had worked on QoE already, and so we did not have to think about like what video quality metrics were important because there was other research that had kind of already defined like, hey, these are the kinds of things that people care about. Like how long does it take for the video to start playing after you hit play, and like what's the resolution? Does it rebuffer? Resolution switches, like, right, that's relates to resolution, but that's a classification problem, not a regression problem. Right? So, okay, cool. So we have like some ideas of the things we want to like measure or get out. We just don't know how we're going to get them. Now, one way to do this, of course, in the way that the FCC did it, like when we worked on the web stuff, is to design an active test, right? So you could like basically design, like in that case, we designed a headless web browser, right, that was running on the embedded device to do all the things. But then you've got all kinds of things to worry about, like am I correctly emulating like how a real browser would load a web page, right? Turns out, like in the case of that web test research, the answer was no, but it was like, look, we're just interested in like time to first byte and like sort of roughly like when things start appearing, so like close enough, right? But now when you get to video, it's like, well, I don't know, how does Netflix like decide like when to switch resolutions, and Amazon's doing that differently, and of course we might do this whole thing and then it might change tomorrow, right? The changing thing is still an issue, but basically what we decided to try was like passive, basically looking at the traffic, and then seeing what we could infer about these metrics from the traces. Now, if the traces were unencrypted, this would be like not so hard. If it's with the traces encrypted, it becomes a little bit trickier, but it turns out that it's doable. There's a couple different steps, and now I'm going to skip over some privacy related things because one of the steps is like you got to get people to like do this. Like how are you going to basically sniff on people's traffic? In this particular case, we had the advantage of the Wall Street Journal's investigative reporting team who wanted this done, And so they just whipped their entire newsroom into shape and said, hey, here are these sketchy devices that are gonna like listen to your traffic, and you're gonna run this for like a couple months and like tell us what you find. And are you done yet? Are you done yet? Are you done yet? Can I unplug this thing? No, not yet. So there are some privacy considerations there that I'll mostly skip over in this talk. But the long story short there is that there's a lot of things to consider there. Step one is like, but as I mentioned, right? So now you got this passive monitor. Step one is like identifying like, do I even have, am I looking at a video stream? And so, but it's all now it's like traffic just flying by and it's mostly encrypted, right? And so, well, this is, I'll say was, at the time, this was a little bit doable by looking at DNS traffic. So we could look at DNS lookups to, let's say, the Netflix CDN or the Amazon Prime Video CDN or whatever. So we had fairly hard-coded exercise, right, to sort of figure out like where were these services like pulling segments from. And then once we had those, we could identify the lookups and then the corresponding IP addresses and then trigger the capture of only those traces. Still not quite done, because anybody who's like tried to watch Netflix knows that like they start playing videos at you the minute you like load the thing, and that's maybe not like you watching a movie, and that's not exactly what we're interested in. We don't want catalog browsers. We want actually someone trying to watch. And so there's another part of the work that involves identifying the session. And then once we have sessions, right, so we have multiple connections, we can associate that with the session. Then it becomes like a machine learning, I'll say simple machine learning problem. And I won't belabor this just for time, but again, basically what we, I won't even say figured out, right? Because we basically snagged everything that we could get and that we could think of, right, at different layers of the stack that we could see, right? And then it's like everything from like packet inter arrival times to like how many connections has this video client opened up in parallel. As it turns out, simple a bit of trivia. We were talking about this with somebody this morning, which is that when the network condition degrades, Netflix aggressively opens up more connections, trying to like desperately save your movie. So sort of, I don't see Justine here. Like this is like expected, but not necessarily good citizen style behavior. But these are the kinds of things where it's like that kind of behavior that then becomes a feature into a model that you can say like, aha, something is going on here. There are things on this slide that I'm also not going to get into like great detail on, but like up the application layer, we can do things like count segments. Like network traffic, as most of you know, I think is like divided into packets, but also videos are divided into like segments, right? And those are the things where it's like download this part of the video at this resolution, and et cetera, and encoded at this frame rate, and those can be adjusted over time. So there's some other things that'll sort of quickly elide that involve like, okay, in the stream we can do things like infer segments as well, and those become features into the model. Yes, question.
What was can't we just record the screen and compare that with the ground truth of this the highest quality movie, and this is what we see?
That's kind of what we did. So the constraint that we were dealing with is like we didn't have access to the clients. We actually didn't want access to the clients for a number of reasons. One is that then you have to instrument the clients. We actually wanted to get this. If we wanted like the sort of canned test, we could have written tests. But what we wanted was to capture the lived experience of people actually streaming the videos, which have come from like a phone, set-top box, browser, tablet, you name it. And so if you really wanted to know, you could go to the client, but like we put ourselves from the perspective of the network, which allowed us to do this like without instrumenting the clients for a wider set of service. Actually, there's a question: could we do it for a wider set of services? But in a, I won't say less invasive way, but just a different point of invasion. Yes.
So in this case, since I may have missed this, but you need to know all the traffic happening in the network, right? Like so from the client's laptop. So you have to do some ARP spoofing or whatnot? How do you actually like make sure that you get all the traffic
We
on
were
your
on
box?
path in this case.
You were on path.
We got on path in this,
Okay,
in this
okay.
case. It's been a minute. I think we were actually on path.
Okay.
There's a couple ways to do it. Like you can set up a span port through a switch.
Yes. Okay.
There's ways to do that. I think actually we were on path.
Okay.
It's been 7 years now, so but pretty sure we were on path. Which is also, sorry, now I digress. But like this is like will keep you up at night, right? It's like to put yourself on the path of a real user who like actually wants to do stuff with their network at home is like a lot of considerations there.
Yeah.
You talk about risks when you talk about your IRB protocol; they go way up, right? Next, so the other challenge, right? So one was sort of featureization, et cetera. The other is like, well, we don't have any labeled data, right? So if we're thinking about this as like a regression or classification problem, it's like, well, how are we going to infer if we don't have how are we going to train a model with like no labeled data? So this we weren't sure it was actually going to even work because it wasn't general. And I'm happy to see VS here because this gets to my next challenge, right? But it was like, how do we get the labeled data? And we did it in a pretty contrived and narrow way, which was just like to your point, like why don't you just go to the client, get it? So that's how we got the ground truth for the models. So we basically went to we streamed it to a browser. At which location there are various ways to get the data about things like frame rate, resolution, performance. There's hotkeys and things you can basically hit to get those overlaid on your video. So we did that with Selenium, and then we basically just scraped that down, captured the packet traces, featureized them, turned the crank on the model, and there you have it. Now, we weren't sure that this was actually going to work because it was like, well, it's not a very diverse data set, training set, right? It's like all streaming to like the browser. In this case, I think it was all streaming to Chrome browsers, etc. To get like a variety of network conditions, like we used a traffic shaper, right? So it's like, oh, well, let's emulate like low throughput or high loss or high latency or what have you. So we turned the dial here in various ways to kind of increase the diversity of what we were seeing in the training set over the operating conditions. But we were like, well, I don't know, like an iPad or a Roku might react completely differently to whatever we're doing here than the laptop. It so happens that it like actually worked worked well enough. But I think, this is, I guess, speeding ahead like a couple slides. I mean, I think a couple people asked me like, what am I excited about now? And I think like one of the areas is synthetic trace generation, because this was an area where even getting a labeled data set was very tricky. And when we did what I just described, it actually wasn't good enough because we didn't quite have enough of it. We didn't have quite the set of diverse conditions. So the model started to overfit to things like certain specific values of packet inter arrival times, like corresponding to frame rates. And we're like, no, we didn't want this. No, this was pre-Stable Diffusion and Doppelganger and like, Gen AI stuff. And so what we ended up doing was taking our traces and duplicating them and adding noise to them and et cetera, and then retraining the model with noise versions of the training set. But if you think about like what might be possible now, I think there's a lot of possibilities and questions that remain there about how to do that. Just for time, I'm going to skip over like the graphs showing the results because, like everything else I've shown you, like they're fairly expected. It's like, if your network is really bad, startup delay and resolution suffer. But like for most operating conditions that users see when they basically buy the basic service from their ISP, it's like good enough. And so the journal loved that headline because it was like a hook, right? And you can imagine now. This was pretty cool because this was like 4 years of work, and then this story hit, and you could imagine they were psyched. I mean, they were like, "Oh my gosh, this is like we got." And then I learned all. It's just brief. I learned all about the metrics that newsrooms keep on their website, even things like the number of paper subscriptions that they get as a result of a click through on an article, down to that. So they're like, we won on like every metric. And on the other side, I had people like my friend and co-author Jason at Comcast calling me being like, we're not so happy about that headline that we just saw on the front page. And that actually is, I think, an interesting digression and lesson that I've really tried to kind of like hold as a principle in the work that I do, because I mean I see other policy interested folks in the room, and I found it like very like interesting and fulfilling and revealing to walk the line between working with industry, working with companies on things that, like, again, these folks actually, they're interested in improving lived experience as well. They're as angry about bad data as like you and I are as researchers. And yet, like everybody in the room, except for, you know, I mean, we all have an agenda, right? Even us as researchers, right? We all have an agenda. And so just trying to figure out like exactly, you know, what to say, when to say it, and how to say it. And like this, I was fortunate on because this was reporter spin and we had papers, right? And I was like, well, hang on, that's spin, right? Here's basically what, you know, our work was really the like inference of quality, you know, video quality from encrypted traffic, et cetera. But I found that like very, just a very, you know, just a very interesting line to walk through the arc here. And actually, at some point, people like got the idea that I did policy, and I like never really thought of myself like I was like I guess so. Like when I went to join the faculty at Princeton, they're like, you do policy, right? I'm like, I don't know, like I do this. But one of the things that I've sort of like that Ed Felton told me when I was at Princeton that I've sort of really kept you know, as a North Star is that, like, you know, as a technologist working on this kind of thing that's adjacent to policy, if people know like how you're going to position yourself on a policy agenda issue at the outset, like you've probably too close to the agenda and not like sticking to you know where you might want to be as far as the tech is concerned. And I've sort of kept that in mind as I continue to do this kind of work. And it was, I think that piece of advice I got from Ed was really helpful because people like Jason, et cetera, they were able to go back to their legal teams and be like, who were like, we fund this guy, like what the heck? And he was like, no, this is actually what we want. We want researchers, scientists doing the kind of work so they tell it like it is, so that when the cards are in our favor, we can point to it, right? And then it's our job as spinsters or whatever to, you know, do whatever it is with the work. But for someone like this, for a researcher, this is what we want because it's credible. And so I learned a lot from that particular experience. Okay, so a couple of quick notes before I turn to the very last part of the talk about like where I think this like what has me excited now, and I think there's two areas that this has really kind of got me excited about. And credit to the students on this is just as you get on in your years, like you run out of ideas, and like the only people who have ideas are the students. And this one came to me like a few years ago because of some people may remember Stable Diffusion and like all these like fancy pictures that these models were generating. And a student came and said, hey, you wrote this paper on deep learning with like packets as images and doing treating packets and throwing them into like deep learning models, which I didn't talk about today, but there's a whole nother line on that. He said, there's this like Stable Diffusion stuff that's out. It's kind of cool, makes pictures. Maybe we can do that with traffic. And then Vias and Julia's work here was like also a great inspiration, the doppelganger work out of CMU. We're like, okay, yeah, that's really interesting. There's a problem set up. This is where like laid the groundwork. Let's see if we can basically do it with packet traces. And they were like, shiny new thing, let's try it. I had no idea, like again, it's a leap of faith. I was like, I don't know what this is useful for, but like, this sounds cool, let's try it. And now I'm like, aha, that's the use. Like, it took me a couple of years to be like, wait, that thing we were working on with the video inference, where we had such a hard time getting labeled traffic, et cetera. I think there's finally a use for this. Anyway, to cut the story short, we tried the Stable Diffusion thing. As most machine learning things, like off the shelf, as it were, like it didn't work quite as you would hope. And we spent like the next, in its ongoing past couple of years, like trying to basically do better versions of that. And again, I mean, I think credit also to to Vyas's group here, who's been doing a lot of really cool work on that as well. Huge inspiration. The other area that I think, like all the stuff I've been talking about, has got me also really excited about, and again, this is credit to students, again, was like, how do you basically make these decisions really fast, right? I actually want to go back. I mentioned on that slide, I mentioned got to do it in real time. And I failed to edit that because like it's not real time at all. Like the stuff we did for the journal was all offline, right? But now, you know, and again, the students came with this idea like, oh, I think we can serve these models faster, like cool. And you know, my typical like mind on that, like being raised through the 90s and early 2000s and networking was like, this is like another make TCP faster era. Like I'm already asleep. But then I was like, oh no, wait, there's so much that like we could do with application optimization, with performance optimization, et cetera, if we could basically make these decisions faster. And so, again, a lot of people working on that, like here at CMU. I think here at CMU, there's like probably the other like big group working on these types of problems. But really, I think super interesting area about how you serve models that make these types of inferences on networks like faster. And obviously security is an obvious application, but I think resource allocation, encoding, et cetera, there's like a lot of things you could do if you could basically make these decisions faster. Last part of the talk. So kind of going back to the whole North Star, right? It's just kind of like, why are we doing this? I mean, I never got excited about TCP performance. I'm sorry to the data center folks in the room too. It just like really hasn't ever excited me. You know, just squeezing the last little like, you know, percentage out of it, it's just like never really excited me. I was like, so let me kind of go back and think about like, well, if my goal here is to like do things or think about measurement in the ways that like, you know, matter to people's lives, like what does that mean? And at the time I had like, this was like 2019. We had actually just kind of finished the work with the journal, and I was thinking of, you know, about the, you know, the FCC broadband maps. Like a lot of people were talking about how bad they were, and then I moved to Chicago in Hyde Park, which is like, you know, near the university, and I tried to get internet installed, Comcast, so they keep featuring, and it was hell on earth. And it involved 6 trucks. And the first time I called them, Lori, you can appreciate this is the analog to the story you're telling me. This morning it was like, call them up and they're like, we'll see you in 6 months. And I was like, what? Come on. So then I called my friend Jason, and I was like, dude, what gives? Like the FCC map here says that you offer 1.2 gigabits in my neighborhood, and your people are telling me 6 months. He's like, yeah, cool, we'll get a truck there tomorrow. Right? So. But I was like, okay, so problem solved for me. But I was like thinking, you know, I'm not in like an under-resourced neighborhood here. And like, this was horrible. Like my experience was terrible. Like, and it's so divergent from like what the maps are saying. And I was like, well, how are they getting this data? And like, you know, it's like not quite the NDT story. It's like a different junk data, right? And it was like, well, come on, we got to actually think about this. Like, and I was thinking like, okay, we know how to do this. I mean, we understand better how to do this for speed tests. We understand a little bit better how to do this for applications. But so far, I've only talked about single user, right? So like, what about like, how would I put it on a map? Like, how would I start to think about like a geography? And that's still keeping us busy. But like the next thing that happened, that was the start of this thing called the Internet Equity Initiative, which we're still running at the University of Chicago. But that was like late 2019, and I don't know if people remember like what was going on like late 2019, like early 2020, but like this pandemic thing happened. And so this happened to me, and then like I was like, maps, we should start to think about this data is horrible. And then the pandemic happened, and people were like, oh my God, the internet's gonna melt down. Like everybody's going home and Zooming. Now it turns out that it didn't. Right, and actually, a paper that I'm not going to talk about today because it's tangent to the broader discussion here is that actually it didn't in large part because our internet service providers, this was a paper they were very happy to read. Actually, it was that our internet service providers, who we love to hate, actually did a fantastic job augmenting the capacity of their interconnects between like, you know, their Access ISP and Zoom and their respective cloud providers. However, what happened, right, is that people were like, well, if you have the internet, it's like doing okay, but if you don't have the internet, life is like now really rough for you. Like it's really tough to participate in life because life basically is the internet. And so at that point we start, again, this is another kind of example of, I didn't think of the questions. We went to our city government and we said, well, what are you thinking about with respect to like, you know, internet access across the city of Chicago and equity? And like one of the questions that came up was like, what is the baseline internet performance level and speed that should be considered acceptable for remote learning? Well, that sounds familiar, right? Because like I just talked about the paper with the journal, except that was Netflix, right? And Amazon. We're like, okay, Zoom. Hopefully this isn't going to be as hard. And that one actually turned out to be not quite so bad. So we ended up working on that a little bit. And this was another great example of like, you know, the questions are out there. If you just ask the people who have the problems, like, and the problem's not solved, like chances are there might be a really interesting, tricky question under there that if you solve it might actually help people. So then the next, you know, the next challenge we faced, right, or another challenge was like, okay, if we want to talk about internet access across geography such that they could put it on a map, well, surely there's like data about that, and then I'll just like throw it on a map, right? So that should be easy, right? So, these are maps of like speed test data across Chicago, Philadelphia, and Washington, shaded in various ways. So like darker is more. So what's the unit here on these maps? Label. You're supposed to always label your units, right? Everybody always tells you that. Your advisor tells you that. So what is the unit on this plot? I've like primed you for 45 minutes. Like, what's the?
Like internet speed.
Yeah, thank you. Great. So I primed you very well. It's not speed. Probably, if you plotted speed, it might look like this, right? So, wealthier regions of Chicago, less wealthy regions, less resourced. Probably it would look like this. Now the problem actually is that we don't super know, because what this actually shows is the number of speed tests people are running in each neighborhood, like a speed test. And so it's like, oh, okay, wait. So now we want to make these points, these policy points about under-resourced neighborhoods, but we don't even have the data to do that. And so I've run short on time to like fully talk about like what we're doing in that particular, you know, and how we're doing this. But what we've started to work on over the last like year and a half is like, if you have a crowdsourced data set like the Ookla speed test or NDT, or pick your favorite crowdsourced data, how do you even talk about performance across space? Like, now policy folks, they like to talk about neighborhoods or like census tracts or whatever, but of course like the internet isn't built like that, right? And so now there are underlying infrastructure facets that are going to cause performance to vary, right? You know, in the old school days, it was like distance from your DSL central office. But there are other things that sort of play into that that maybe have nothing to do with how an administrator or a bureaucrat decided to draw like a neighborhood boundary. And so I'm going to skip the details of that, which are in a Sigmetrics paper that appeared just a couple months ago. But essentially, again, that was a credit to the student who really thought about spatial sampling models, and those were actually borrowed from astrophysics, actually. Since we're a little short on time, I'm going to skip over like a couple of other just like teaser pointers. But everything that I've talked about here is like available through open source software and data sets, et cetera. I'll give the deck to Yuvraj so that you can have the pointers. The other thing that that I'll just briefly mention before concluding is that there's a lot of things that, like, when I started out on this work, like, oh, interesting questions, societally important problems, I thought were at odds. And I was like, you know, I've also started off thinking like, well, these are academically interesting questions, but surely like, you know, there's not more to it. Turns out like Comcast, right, they're back in the story. They're like, oh my gosh, we're deploying all these like low latency technologies, et cetera. There's something called low latency DOCSIS. There's another thing called L4S, which is like, essentially, it's for the old networking folks in the room, it's differentiated services. It's like dual queue for low latency. they've got new names for old things. And they're like, well, we don't even know if it works. And also the technology that we have in homes is so old, right? The modems, we don't even have the capability to measure speeds. So like, turns out you know how to do that. Can you help us? So there's commercialization paths here too. And I guess in synthetic data generation as well, it would seem there are as well. So let me kind of conclude then with a couple of final slides. One is that like, I did not expect to be working on this 15 years later. I actually thought this was going to be like I was like doing network security, spam filtering, botnet detection, still kind of do some of that too, I guess. But this was like a sideshow for me, right? And then it's just so turned out that like this data set that was dropped in my lap was unsatisfying. And then I realized, no, wait, there's like a huge problem here. And then just by keeping that question, the North Star, right? Like, well, what are we doing here? We're not actually trying to build a better speed test. We're actually trying to get data about an artifact, in this case, the internet, that helps us speak to like what people are actually experiencing on the internet. And over the years, like the ground keeps shifting, like the access networks get faster, like the applications change, our capabilities to do things like, the Raspberry Pis didn't exist when we started, right? Machine learning it existed, but it's certainly not what it is today, right? So all these things have, the ground has shifted, but the underlying question of like, what are we trying to do? We're basically trying to make people's lives better on the internet has continued to stay the same. And so I kind of wanted to end there with that and a couple other thoughts, which is that like, really by kind of having a North Star like that, you can kind of continue to keep working on something. And you don't have to imagine the problems because real people have them. And the theme that kept showing up in the work that I was presenting was like, as I said, I didn't think of any of those questions. I got them because people came to me with like a question and I was like, oh, wait, like that sounds like a simple question, but if you don't have like the answer, like maybe there's a hard problem in there. Now I just got to figure out what the hard problem is. And with the mapping stuff, when I presented it to my students, like I was like, I think there's something here, folks. And they're like, yeah, isn't it just like some econ policy question? Like, I don't know, is there computer science in there? And I'm like, I don't know. I mean, there's definitely econ and policy, but like, also we know that it's hard to measure networks. So like something has got, sure enough, like, yeah, we can continue to turn the crank on CS research. The final thing that I'll say before my final thing is that like, I'm able to give this talk and like go to nice places and visit and meet with really smart people like all of you because of the people that I've worked with on the problem who've changed and shifted a little bit over the years. But I would say that like, again, I didn't think that I was going to keep working on this or like I didn't even think that I was going to be working on this at all. But I've been kind of led through these problems by people that have been pretty smart people, but most importantly, nice people, kind people who are fun to work with and who I've learned a lot from. And so I think like that's kind of where, where I'd sort of leave it is that don't worry too much about like the specific problem. Find the right people and ask questions and listen to the questions people are asking, and the problems will find you. And I want to kind of end with this point, which again is not my idea either. I stole this from Nick McEwen's SIGCOMM keynote from like 2012 when he was talking about software-defined networking, right? And he wanted to just shake up networking technology, and people were like, "Okay, cool, but is there like any intellectually interesting idea there?" And it turns out there is. But he said in his talk, it doesn't have to be a conflict between an intellectually interesting idea and improving the practice. And so I stole that and I added a third one, right? It does not have to be a conflict between broader impacts. Are we still allowed to say that? Like broader impacts, advancing societal goals, right? Improving the practice and doing things that have deep scholarship. And so hopefully I can leave you with that in this talk. And then finally, final point is that, remember, like I constantly remind myself, like, why am I doing this, right? Because when you came to grad school, did you even like know what a paper was? Like, did you know how to write it? Like, and then suddenly you get in this rat hole where it's like the only thing that matters is like how many Usenix papers you got. Like, I mean, really? Is that all that matters? And I mean, yeah, it matters, right? But like, why are you writing the paper? You're writing the paper so that someone reads it, so that you're writing the paper because of the work that it represents, the artifacts that it produced, so that people can, and whoever your people are those customers, are those regulators, are those advocates, the people you want to pick up your work and do something with it. So I'll leave you with that. Thanks.
So we have time for some questions.
Yeah. Would you say that current ISPs or that ISPs are currently overselling their capacity? Like, for example, I imagine that in cellular networks, when there's a fire, like in California and so on, everyone's trying to call, but at a certain point, no one else can call because the lines are saturated. So I'm kind of imagining that could also happen with the ISPs. Do you know about that?
This is an area where like the situation has shifted a lot, like over the last 10 years. So if you asked me that question in like 2013, 2014, I would have said like, yeah, there are capacity problems, and there are like very specific points in the network, and the interconnect was one. John Oliver actually had a lot of interesting pieces on that. Prior to that, like the access network was oversubscribed, under-provisioned. These days, I'll tell you one anecdote I heard that kind of sums it up, is that like all that stuff kind of like went away with cloud native apps, because the ISPs themselves are running all their operations on the cloud as well. And so they're like, we're not going to under provision to Amazon and like Google and all these places, because like all of our stuff is also running in the cloud. And so, and also bandwidth became a lot cheaper. And so like the issues of bandwidth, like provisioning have, obviously that doesn't pertain to the access thing, but the issues of provisioning have not completely gone away, but they're not as front and center as some other issues now. Because you think about like what people are doing, they're doing like gaming or video conferencing or whatever. These are not like super high throughput applications, but what they are is latencies. A lot of them are latency sensitive. And so latency is now, I'd say, has become a thing. I think as we start to hear over the next like 5 years, I think we're going to hear more and more about latency, because Comcast no longer has the provisioning problem, but they do have a market problem, right? They have like these fixed 5G providers, and they have like LEO satellite providers coming and saying, you don't need that thing. You've got like, hey, we've got high throughput, like, and you just have to put this thing on your desk. And now they're like, oh, shoot, like we thought we had this market locked because we're the only people with fixed line in this neighborhood, and now these people are beaming in. Those things still have some latency issues to iron out. So I think, and also the applications we're using now are much more dependent on latency. So I think that's an area where where we continue to see bottlenecks. Yeah.
Yeah, I guess so. In spirit of like looking at different applications, you looked at like streaming services and video conferences, and now we live in a world with like obviously LLMs are this amazing new shiny tool that everybody's using. I assume measuring the speed the LLMs are servicing across like the network, is it almost like a different problem because you don't have like caching, you can't like cache the LLM output. I don't know, is there any like work to be done on trying to measure like if you're in a certain location, are you gonna have like faster access to like GPT, or is it gonna be really slow in like a rural area?
Yeah, I'm a little out of my depth on that. I mean, I think the only thing I can say about that, just based on like the work that we've done on model serving, is that like the network is not the bottleneck in serving some of those models. It's the model. Yes, Lori. No, I'm done. Yeah, you have something to say on that?
Yeah, so I was wondering, have you had any involvement in the FCC's broadband label effort?
A bit. So there was a group called the Broadband Internet Tech Advisory Group that wrote a report on broadband labels, and like there was a movement for machine readable labels, like what should go on them. And so I was like in the working group that wrote that produced that report that was then like sort of put to the FCC. I can't claim to be an expert though. I mean,
I have two questions related to that.
Yeah.
So I am not an expert in this,
Yeah.
and I inadvertently got myself involved in the broadband labeling.
Oh, fun. Yeah.
Because it was an opportunity to spend 3 months working on this and make a difference, right?
Sure.
And so we very quickly, we as myself and John Piha, and students wrote a report on what we thought should be on the broadband labels.
Okay,
Right,
I think I probably read that without, yeah.
And the FCC took a few of our recommendations and ignored most of it.
Uh-huh.
But there were two things that they ignored that they might have ignored because it's not entirely clear how you do it. And I'm wondering your thoughts on this. So one was instead of just putting speed and things like that, it would be useful to have a thing like suitable for streaming, excellent for streaming, terrible for streaming, suitable for web browsing, right? Those sorts of things. And then the other bit is outages. When we surveyed consumers were like, Comcast goes down all the time. I want to know how often it goes down. And one of the problems with reporting outages is how do you define outages? How long does it have to be down before you count it as an outage? How do you do that? So I'm wondering your thoughts on those two.
Yeah, let's see. So the second one was outages, and the first one was application. Yeah, so on the second topic, Fabian Bustamante at Northwestern and Zach Bischoff had attempted to define outage, and I mean I worked on that paper with them a while ago, and you hit the nail on the head. It's like nobody can agree what constitutes an outage, and it's sort of I couldn't even tell you myself, even having worked on it, because there's all these metrics that we learn about in systems engineering, right? It's like, mean time to failure, and mean time between failures, and mean time to repair, and you can compute all that stuff, but if you have an outage in the middle of your Zoom call of a really important interview, that's a little bit different than a 30-second hiccup in your Netflix stream, which you may not even notice because the whole thing's buffered, right? So it's how do you even define it? So that one's tricky. The application, and that comes to the application one, which I don't know what who was in the room when you were talking about those things, but it reminds me of my first visit to the FCC when we started working on this back in 2010 or so. And I was like, okay, we know how to do this. I'm just going to tell them it's going to be great. And then I realized, to your point earlier, I was in a room full of lawyers. I very quickly realized that because somebody got up and said well, I don't really think we need latency. Nobody understands that, and that's just some confusing metric, and we should just do throughput. Everybody knows what that means. And I was like, what? Then I learned out, this was basically lawyer lobbyist for HughesNet, the satellite provider. Of course they're not interested in and I'm like, oh my gosh, I'm playing 4D chess here, and I'm just some networking nerd in the corner. That was I knew that policy was going to be tough at that very moment. Yes.
Thanks for the shout out to Julia and my work. She deserves more credit.
Yeah.
She's the brains behind the project. I just came with the question.
Yeah.
So I have a meta question, right? So you have these advice slides. I remember listening to your advice slides in 2010 at your Rising Star keynote. Rising Star. I mean, that's one of the awards he has won, many awards. So how have your advice bullets changed in the last 15 years? Or are they the same bullets?
Oh, that's a great question.
I'm curious to see a delta on your advice bullets from 2010 to now.
Yeah, that's a great question. I mean, I don't think what I'm about to say is unique. You probably resonate with this yourself too. I'm curious to what other senior faculty in the room think. But I can look back at a lot of projects I worked on at the beginning of this arc that were not what I talked about. And they're good, I'm that's a good paper, but I'm I didn't need to write that actually. It's that, and it's good. It's a highly cited piece of work. It's high quality, great, got some citations, but I'm if that paper didn't exist, probably the world would be the same. And so this is a question, I guess, to your question about how I thought about advising. It's really how I've changed how I think about my own work. Is when a student comes in, to the point of this transformer stuff or this generative stuff that you're also working on. I'm oh, this is really cool. We could basically take this new SSM Mamba thing and throw traffic at it, and we can do better than the last paper. And I'm well, why? I mean, yeah, I'm sure we could, but my first question is why do you want to do it? And it's there's a bunch of like words in that sense. One is like why, like the other is you. So the other thing that so I try to do the Shapley value on my research, and I sort of like ask the same question to my students in advising. It's like, if we didn't do this, would anything be different? And it's like, well, if this research didn't exist, like, would the world be any worse off? Like, sometimes it's hard to predict, and so maybe you take a leap of faith and do it anyway. Like in the case of the generative stuff, I didn't know, so it's like, I don't know, but at least we asked the question. The other question I ask the students especially is like, yeah, what if this happened but we didn't do it? Like, do we need to write this paper? Or if we didn't do it, would someone else go write it? And so like people, I think like especially junior folks, students, like so like, you know, can be obsessed about getting scooped. And when I'm thinking about something and somebody else writes the paper, now I'm psyched. Students like, oh man, can't write that. And I'm like, no, we don't have to write that paper. We can write a different one. And so I think that sort of style and philosophy has really changed, because it's sort of like gained a little bit more perspective as to like, okay, well, there's certain things that like only I can do, or only my students can do, or only myself with like these collaborators can do. And then it's like a really happy place to be, because I'm like, well, I feel like I'm adding value by doing this. And I don't get stressed necessarily that like somebody else is going to do it, because I'm like, well, I'm doing something that like adds some value. And then I don't know, I think like students feel less panicked too, at least I hope they do. And I think I find that a little bit more fulfilling. So I think that's shifted over the years.
Great talk.
Thank you.
I like this notion of lived experience.
Yeah.
A lot of the data analysis seems very centric in North America. How do we think globally about this notion of lived experience? I know you've worked in other places, but I think, how do we do that? How do we get data? How do we get participants?
Yeah, that's a good question. And I think you've done some work abroad, right? Like I'm trying to follow a little bit of what you've been up to. I don't know. I'm trying to answer that generally in a way that like doesn't point to just like a study we've done, because like, I don't know. Let me start with like a rant, and then I'll just like end with a more specific point, which is that like as a submitter to these measurement conferences yourself, you know that and it comes to the spatial sampling question. It's like, well, this isn't representative of anything. You've only deployed this in 100, and it's like by people who don't even understand statistics, right? How you don't even know what a sample error is, and you're telling me it's not representative. But I think basically, I don't have a good answer to that, because I don't think there is such a thing as a representative sample. And I think like you've done, I think, some work in the global south, and like we've done a little bit as well, like over the years, to note that like paths are completely different. Technology is different. Like the location of the data centers with respect to like where people are is different. I thought we were going to do this study at some point in like West Africa. Some people called us like from Nigeria, and I was like, cool. Oh, except there's no like there's no like wireline there. So it's like, all right, guess not, right? So I don't know how to answer that question. I think it's a really good one. I mean, I think certainly, I just don't know. I think maybe some of the work that we're thinking about now in terms of like spatial sampling can start to speak to this, because I mean, the other thing that got like really kind of started to like cause an itch for me was like all these reviews that were like, this is not representative. How can you talk about like the internet speed in like Illinois when you have this many users? And I'm like, well, you know, if it's like the variance is 0, you need like 1 point, right? So like, but obviously it's not that. So I was like, but I don't know how to answer that question either. I'm like, well, you know, like screw you guys, it's representative. But it's like, I didn't have any standing for that either. And so I think now maybe as that might be the next step, is to think about like, okay, we know how to do it at point measurements. We're starting to think about space. Like we're starting to think about time. Once we have those methods, we could then start to ask like, well, how does what I showed you in Chicago, how does that differ from like where you're trying to do measurements? And like, do we need different samples? Do we need different kinds of tests? Like, I mean, I think maybe it'll keep us busy for another 5 to 10 years, but I think this is a super good question. I don't have like a good answer for you yet, but we should work on it.
Can I ask another question?
Sure.
It's a little related, but so I think we make a lot of generalizations, and there's a geographic bias in the data we have, and we make global claims from this very biased data. have you started to look into kind of how do we disentangle some of this geographic bias? I think like you take a look at a census, for example.
Yep.
You count the number of people, but you have some notion of a ground truth and you try to correct for that.
Yeah.
Is there some parallel to networking where we might not have data from everywhere, but we know some notion about the characteristics of the other places, and we can use that to maybe limit or add caution to our claims? We don't add caution to anything, but maybe.
Yeah, I mean, I think this is maybe the next talk I give on this is like the spatial sampling stuff, which I went over super quickly. There's another line of work that we're doing, which again, this is like in collaboration with people who know more about this kind of thing than me, is like using multi-level modeling. You can basically take spatial samples and then figure out like, what are the main explainers for variance in my data set? And now you could say like, well, within this region, is it like, I could take lat longe or something. Is that an explainer? Like now I basically look within a tract, and now if I've got other factors like, is it single family home versus like apartment or whatever? And so there are techniques like multi-level modeling that one can use to try to do things like explain sources of variance in the data set. But again, this is an area where like I've only started to learn how to do that. But I think to your question about like understanding limitations of a sample, it is right on point. I mean, that's if you want to think more about that, like call me up, because that's kind of that's where we're headed now. So.
Well, let's
Thank you.
for
Thank you for having me.